In this presentation, I'm going to talk about the SinoBit. This is a Chinese equivalent of the microbit computer. The microbit computer is a small computer introduced by the BBC for STEM education. So I'll be using a mind map starting off at the top right, moving clockwise. I'll describe the microbit, some of its features and its hardware, what sort of software I've been using, and some of the projects. Then I'll critique it to see whether it's a worthwhile development. And finally, I'll give you some of my references. So microbit is a lot bigger than the microbit and a bit more expensive. So I can buy microbit for around about $20, and the regular price for SinoBit is about double that. But you can see the graphics are a lot better than microbit, and that's because microbit only has an LED display of 5 by 5 pixel array compared to the 12 by 12 pixel array on SinoBit. And looking at the philosophy behind the design, there's a lot of Chinese philosophy has come into that. And you can see that when you look at the feng shui and the other Taoist influences on its design. But this is a little bit superficial anyway, because it's more of the feel of the board rather than its functionality electronically. So there are many items like the accelerometer and magnetometer are the same as the microbit. The LED array is bigger. It has the same number of push buttons, that is A and B, but they're in reverse order. It's got a serial port, Bluetooth, and you can add external battery to it. And one of the great things about it is it has Grove compatibility with 2 Grove ports. So you can put Grove devices and connect as a serial device on the UART, or alternatively connect to the I2C port. And here are some of the hardware functions. It's fairly open source and documented to the extent that you know where all the pins are. And most of these are compatible with microbit. So that's a big plus. The LED array is totally different. And Holtec HT1632 chip driver is used to drive the LEDs on SinoBit. For the software, you can forget about Microsoft MakeCode. It certainly doesn't support the graphics, and the only code environment that you can use is the Arduino IDE, although perhaps Python might work, but I haven't tried that. So there are plenty of libraries available, and Adafruit has put in a big effort to help you with your SinoBit projects. So Adafruit has created examples that allow you to learn how to create graphics and control the LEDs. All the GPIO, UART, and I2C are no problem at all. So if you're familiar with the microbit, for those I/O functions, you'll have no problems at all. And some of the very traditional games like Conway's Life Game will work quite nicely. And with the better graphics, they are quite convincing, and you get a much better display on SinoBit. So I've created 4 projects, and I've also been exploring the compatibility with microbit. So best to start off with exploring and learning the graphics. And I've done this by recreating a project, and we'll have a look at that one. And one of the initial ambitions of SinoBit was to have a computer that allowed Chinese characters to be readily displayed. So we'll have a look at a name badge, and I'll explore the use of environmental monitoring using the BME 280 as a I2C interface to SinoBit. So here's the Christmas tree. And it was a good project just to learn the graphics. And this is already online as a project. It's one of the very few projects that's been documented in a blog, and you can go and get further help on this project. The good thing about it is that it shows you the coding of the pixel array, and you can put that code into a Arduino IDE C++ program. And it looks a little bit like this. So if you take row by row, there's 2 bytes. So this particular array has 1 row for each row in the LED array. So you might notice that the first byte is a hexadecimal, and the leading hexadecimal character represents 4 LED bits. The next hexadecimal character represents the next 4 bits. And as we move across, we only use the leading hexadecimal character for the remaining 4 bits of our 12-bit LED on a row. So from that, we can progress to exploring how we can get Chinese characters on. And again, this is a project that has already been completed on the internet, so you can look at my references to find that. But I've also developed a procedure for drawing Chinese characters. And it's not an easy process. You have to scale down from a existing Chinese character to the 12 by 12 bit array. And not all Chinese characters will work in that format. So you can only put a few Chinese characters. So it's more for display and more for presenting that concept. Luckily, Arduino and Adafruit have come to the rescue. So Adafruit has created a good graphics library that allows you to draw graphics either pixel by pixel, or alternatively, you can draw circles, rectangles, or lines using simple commands, Arduino commands. Using this code generator, you can draw a Chinese character, scale it down to the 12 by 12 and 12 by 12 pixel array. And this program on the internet will allow you to generate the Arduino code for that image. So all you do is scale down, and stretch to fill the canvas. Just watch the preview and you'll be able to generate code like this. And you can use that in your template program. So creating a name badge is quite simple. And my program just uses the buttons to show my surname and first name. But this was also a exercise in learning about the graphics to learn to draw lines, rectangles, circles, and even text. Text is a bit harder. I was able to get the scrolling to work either from left to right or right to left or top to bottom. So that's another feature which is implemented on SinoBit, but not on microbit. And the final project I attempted was showing the environmental parameters of temperature, pressure, and humidity from a chip called or a module called the Grove BME 280. And you can see it on the drawing here. It's in a Lego wrapper, and it's connected directly via a Grove cable to the upper right Grove connection on SinoBit. So on the left photo, on the top one, we've got a measurement of temperature. When I press the A button, which is on the right, we can see the temperature is 14 degrees, a cold winter's day in Sydney. And when I press the left button, which is button B, I get the humidity. So in some ways, it gives you a much nicer display than the original microbit. But one of the problems is that I can't retain a static display for 2 digits. So you think that would be easy, and theoretically it should be possible. But the only display I can get is a scrolling display. So my objectives for this project was to test the I2C software and interface on SinoBit. I picked a device that doesn't draw much current, and the BME 280 allows me to do that. And the objective was to print the temperature and humidity on SinoBit. Press button A for temperature and button B for humidity. I also wanted to get the results from the BME 280 onto the serial monitor and check that I'm getting all the results. So this is what some of the code looks like, or at least right at the start, and some of the libraries that I'm using there. So there is a library called the SinoBit library, and I'm just adding the seed BME 280 library so that I can simplify or reduce the time that I put into the project. And I create a function called getEnvironment to get all the environmental parameters and print them out. So getting the temperature, pressure, and altitude and humidity is fairly easy if you're using the library functions and APIs that are made available to you. So overall, does SinoBit work? It was originally created as an alternative to microbit and as an alternative to using English-only characters on a display. But it really doesn't achieve that goal. It's actually quite a long process, and you can't get many Chinese characters, even with a 12 by 12 bit array. You are still limited in the number of characters that you can represent. I think one of the disappointments is that MakeCode is not supported. And that's a big limitation in STEM education. And it certainly didn't achieve its original goal of having embedded Chinese characters. Also, while it was announced in 2017, we're now quite a few years after that, and nothing's been published on the internet since 2018. So in some ways, I would think that the SinoBit is dead. There is no further development of it. But it did have a few good things. One good thing was that it had Grove connectors. And unlike microbit, you didn't have to go and buy extra hardware to interface it to Grove electronics. So the graphics are much better, and you can achieve some really good results using those graphics. And you've also got some support using the Adafruit GFX library and APIs. So while I've said not tested, I've now tested some of those, and they do work. So there are some differences, but overall, if you're using the Arduino IDE for your software development, you'll have no problems at all. It's got some issues. One is that I'm not sure about the current limitations, and I don't want to add devices like LEDs on my Grove connections, as I might destroy my SinoBit. And there's nothing published. The original developer, Elecrow, they have nothing at all to help you, either with the hardware or with software. And in fact, the only help they have is to refer you to a Adafruit website, and it's not bad. So if you want to do any development on this, go to the Adafruit website and you'll get plenty of support there. So here are some of my references. And as I've mentioned, Adafruit have done a good job. And that might be partly because the graphics driver and the LED driver all come from Adafruit, and the software source comes from them too. Now, here are some of the other references that you might like to have a look at. And overall, it was an interesting project, and I'm still working to explore some more about the compatibility with microbit. Thank you for listening.